Hello, everyone. Welcome to Cloud Folklore, where we'll unravel the mysteries of the digital sky. My name is Goodness Ebel, and today we'll be diving into AWS load balancers. Well, a load balancer helps distribute incoming network traffic across multiple servers. This ensures that no single server becomes overwhelmed with too much traffic, which can help improve the availability and reliability of your application. Now, AWS actually offers three different types of load balancers. We have the network load balancers, we have the application load balancers, and we have the gateway load balancers. But we'll be focusing on the application load balancers for this lecture because we are working on rendering a simple web page via HTTP, and the application load balancer is the one suitable for such attacks. This diagram breakdown features a user, an internet gateway, a load balancer, VPC, a target group, and two EC2 instances where our application will be loaded from. Well, the users actually represents the end users who are trying to send requests into our application, right? Through a web browser or mobile app, something like that. While the gateway allows traffic from the internet, that is from these users, right, into our VPC, our virtual private cloud, right? Then we have the load balancer. The load balancer sits between the users and the EC2 servers, right? In this case, EC2 instances are acting as our servers, right? So it sits between the users and the servers, and in this case, which is our EC2 instance. Now, what it does is that it receives incoming requests. The load balancer receives incoming requests from the users and distribute them across these servers in the target group. Then we have the VPC. Now, the VPC is this shield you see right here. Right? The VPC is this is like the virtual network in the cloud where the load balancers and our servers, in this case EC2 instances, reside. It provides some kind of isolation, right, and security for our cloud resources. Then we have the target group right here. Now, this is a group of EC2 instances that the load balancer distributes traffic to. So basically, we have our servers here. The target group helps box them up into a single target where the load balancer distributes traffic into. There are two, but they'll be inside one target group. You can have multiple servers in this target group. It doesn't have to be just two. You can have three, you can have four, right? Just based on your own preference and what you want to use it to do, and how much load or traffic you're expecting. Then let's discuss the process flow further, right? So the users sends requests into our application. Now, this request first hits the internet gateway, which then allows the traffic into our VPC, right? Now, these incoming requests are then directed into this load balancer right here. Now, the load balancer is responsible for managing these requests and distributing them across our servers, right? Now, the load balancer distributes these incoming requests down to our EC2 instance inside of this target group right here. Now, this distribution can actually be done in various algorithms, right? You have the round robin algorithm. In this case, you'd see that each server is used in turn according to like a predefined sequence, right? Then we have least connections. This is the one where traffic is sent to the server that has the fewest active connections, right? Then we have IP hash, where traffic is distributed based on some kind of hash of the client's IP address. Then we have the EC2 instance handling this request, when they receive the traffic from the load balancer and process this request. Now, these instances are where our applications are running, right? So now this instance processes this request, then sends the response back to the load balancer, which then forwards it back to the users. So that's how this whole process flow works. And what are the benefits now? Now, when you distribute load across multiple servers, now you can actually handle like a large number of requests efficiently. You no longer have to worry about this single server would have too much requests and it might crash. Now you have other servers that will be able to handle this request, so it brings about some sort of scalability. Now, if one EC2 instance fails or if one server fails, in this case, now the load balancer can redirect traffic to the remaining healthy servers. Like I said, it doesn't have to be two, it can be multiple, it can be four, it can be five, depending on how much traffic you expect. Now, the load balancer can now manage traffic across multiple servers in multiple availability zones. for greater redundancy. That brings about some sort of flexibility. So you have multiple instances on server across multiple availability zones, because definitely you wouldn't put all your servers in the same availability zone. If not, it's going to be redundant. It's going to like defeat the purpose of actually having multiple servers in the first place. The idea is to have your servers in different availability zones, so that in case there's a problem with one availability zone, you can easily shift to another one. So we'll do the demo, right? We'll do the demo. I just want to give you a breakdown of the process flow so that when we are working on it, it will be smooth. So let's head on to our AWS account where we would carry out the demo. So we can decide to create a new VPC, create a new subnet, then an internet gateway, then a route table, but I wouldn't go into that in this video. I'm just going to use the existing VPC built by AWS. So we're just going to go straight to creating our EC2 instance. We'll be using Virginia, US East 1. Let's launch our instance. The first one will be called EC2 1. We're using Ubuntu. We're using the free tier. We could create a new key pair. Let's call it LB. Let's call it load balancer key pair. Load balancer key. Yep. Will allow HTTP and HTTPS traffic. Yes, I did this. We're using this VPC, the default one provided by AWS, but we're using availability zone 1. And you can see that each of these subnets are different, and each of them have the same VPC but a different availability zone. So this is the setup we want to use. So I'm using 1A for EC2 1. We could leave our configuration, our storage space like this. This is fine. Now let's go into advanced details. Now in advanced details, I just want to put in a command here. This script here would automatically update our repository index, install Apache, start it, then push out this message to our web browser, so that we'll be able to identify our servers. So for this server 1, it's going to say hello from server 1. So this is fine. Let's launch this instance. Now, whilst this instance is getting load up, where's our news appeared? So while this instance is getting load up, let's create a new one. It's pending. Let's launch a new instance. Let's call that one EC2 2. That sounds kind of funny. Ubuntu, we're still using the free tier. We'll just use our load balancer key. We'll allow HTTPS and HTTP traffic, but we're actually going to be using just HTTP if I'm being sincere, but let's just allow both of them in case I get inspired to do something else. We're using 1B availability zone for this one. Storage is fine. We're going to copy the same scripts I'm putting here, but the only difference is that we're going to change this to hello from server 2. That way we'll be able to identify our server 1 and our server 2. I'll launch the instance now. Let's check if our instances are running. The first one is running. You can see initializing. So let's wait for a bit. Once the both of them are running, we would see it in the. We actually choose a particular state, rather a particular state we want. We can leave this at running. Yes, okay. So we'll be able to see just the two that we want to use. So when these are totally up, it's actually carrying out status check at the moment. But once they are fully up, we're going to get back to our tutorial. So our servers are finally up and running. Let's pick the first one, copy the IP address. So this says hello from server 1. Let's pick the second one. EC2. So both are running. This first one says hello from server 1. This says hello from server 2. So they were successfully launched. Let's go on to creating our target group. That's what we need to create next. So within this EC2 dashboard, scroll down to load balancing. In load balancing, scroll down to target groups. So we're going to create a new target group. Well, in target groups, we're going to hit create target group. So there are actually different types of target types we could choose. We have instances, we have IP addresses, we have the one for Lambda function, we have one for application load balancer, but we'll be using this because this one supports load balancing to instances within a specific VPC, which is what we did. This other one offers the flexibility for a network load balancer, to accept and route TCP requests. We're not using this. This one supports load balancing to VPC and on-premise resources. We're using cloud resource at the moment, so no, I'm not using an on-premise resource. So and this is for Lambda function. So let's just give our target group a name. That will be target group. We're using HTTP, port 80, IPv4. This is fine. We'll be using this availability zone because that's the one we used for our instances. Now, if we had created a new VPC, then that's but I will be using this VPC because that's the one we created for we used for our instances. Now, if we had created a new VPC, that's the one we'll be using. We'll be using HTTP 1. This is okay. So since we don't have a complex website, so the out check will just go from the roots. We go to next. This is nice. So we'll pick out our 2 instances that are running that we want to use. We include them as pending. We'll scroll downwards. Then we'll create the target group. So at the moment, this will be showing unused. That's because we've not attached them to a load balancer. So let's quickly do that. We'll scroll down to load balancers now. Now click on create load balancer. Now the application load balancer is suitable if you need advanced routing features, operate a microservice architecture, or require support for WebSockets, on HTTP2, HTTP1, and it is suitable and ideal for HTTP and HTTPS traffic. So that's the reason why we're using application load balancer. Now the network load balancer is appropriate for high throughput applications, real-time streaming, or low latency requirements. It can handle millions of requests per second. It's best for UDP and TLS traffic, where high performance and low latency are critical. So that's for network load balancer. For the gateway load balancer, it's ideal if you need to deploy and manage third-party network appliances or applications within your AWS infrastructure. It's good if you want to design and deploy something like firewalls, intrusion detection prevention system, things like that within your AWS. Then you can use gateway, but we're using application load balancer. Let's give the load balancer a name. Let's call it Apache load balancer. I'm actually not good at naming these things. We're using internet facing. An internet facing load balancer routes requests from clients over the internet to target. So this is what we're using. We're using IP address type IPv4. We're using this VPC. We're just going to choose US's 1A and 1B. That's what we chose for our subnet. It said select at least 2 availability zones and 1 subnet per zone. We should just go with this. This is fine. There's nothing complex in this. What we're doing. For security group, I would encourage you to create a new security group for your load balancer. So let's quickly do that. Let's hit on this. Open up a new tab. I think security group is within EC2. So open up a new tab in EC2. We should see our security groups here. That's right. Then let's create a new security group. Let's call it LB security group. Let's give the description allows. Let's give the description allows access to our servers. Allows the okay, this is fine. We're using this VPC. This is the only one we have anyway. Let's add inbound rule. We add HTTP anywhere. This is fine. We can add HTTPS if we want. Anywhere as well. Outbound route, yeah, all traffic is fine. Create our security group. Now we're done doing that. Let's go back to our application load balancer. Now we can attach this security group. Let's refresh. Okay, this is it. Load balancer. That's great. We're using HTTP port 80. Our target group is this one. Let's scroll down. So this is a summary of what we've done so far. Basic configuration, we're using internet facing and IPv4 for Apache load balancer, for our load balancer. Then we're using this security, the default security group and the load balancer security group that we created. For the network mapping, we're using this VPC, the default VPC, and we're using availability zone 1A and 1B with these subnets. So this is fine. We're using this target group, right? Create our load balancer. Now the load balancer takes about I think 2 to 3 minutes to provision. So let's give it a bit of time, then we'll get back to the video. So our load balancer is fully provisioned, it's active. Let's go into it. So if you'd used a domain name and attach it to our Route 53 and all, that's the DNS name we would have used, like your domain name. But since we don't have that, we're going to use this DNS name provided by our load balancer. Let's paste this. So this should give us access to the servers. Now, if we refresh right here, you should see server 2. Yeah, exactly. So refresh again, you see server 1. After sometimes, yeah, exactly, you see server 2. So what happens here is that let's imagine that there are various users, there are multiple users trying to access this our website. Sometimes the traffic will be routed to server 2, sometimes it will be routed to server 1, right? So you can actually specify how you want your traffic to be sent to those servers. You can do 50-50, you can do 30-70, depending on how you want to set up. But we're just doing a basic setup in this video, so we won't get to all that. I think that's all. I think I can add something. I think I can add a bonus knowledge. Okay, so let's add something. So if we drop these IPs here, let's stop this instance. You'd see that now. Let's take note. This is the let's take notes. These are the IPs that came with it. This one is 95.21.190 for EC2.2, while this for EC2.1 is 3.238.758.8, right? Now, when we stop these instances, you'd see that this IPs gets this deassociated from the instance itself. Let's give it a bit of time. Let's just stop that one. So yeah, so yeah, you see now the public IPv4 address is no longer available. And if we try to start it again, you see that will be allocated a new IP address. So let's start these instances. Let's choose running. I don't want all this drama on the screen. When it's up and running, you see it here. So our instances are up and running again, and if we check, you'd see that we have been allocated a different IP address. We copy this one now. This is the one that would work for our server, right? But we can actually use a more permanent IP address, right? We are using Elastic IPs, so we could go to Elastic IPs right here, create or allocate new Elastic IP. Okay, the first one, let's allocate another one. Same US one. We're using US one, yeah, so that's fine. I don't want to attack, so I just want to do something quick. But then should be up. Yeah, so let's attach this one to our EC2 one. Associate IP EC2 one. Yes. Okay, specify reassociation. Specify whether the IP address, the Elastic IP address, can be associated with a different resource if it's already associated with a resource. So that's fine, we can do that. Associate. Do this for EC2 one. For EC2, so for this, let's attach this one to EC2 2. Allow. Associate. I think this should be fine. Let's go to our EC2 dashboard now. You'll see that our IP address are no longer these ones that we have up here. We should have the Elastic IP attached to it, more permanent. So we can copy this and check if it works. So it works for server 2. Let's check the one for server 1. Right. Now, if we drop our instances, let's stop them. You'd see that the Elastic IPs will still be there, irrespective of the fact that we'll stop them. That's because these ones are more permanent. They do not change like the other one that comes with it. You see, if we refresh, still the same thing, right? Now, if we try to start our instances again, okay, it's still stopping. Let's just hold up until it's completely stopped. If that stops, and if we go into the instances, we'll see that they are still available. Our Elastic IPs are still available. So if we'd start them again, you'd see that we're still going to be using exactly the same Elastic IPs. Let's change the state to running. Yeah, so it's running now. You check, you see that it's exactly the same IP address that we had previously, that we still have, right? We go to the second one, EC2 one, rather the first one. See that it's exactly the same IP address that we have. And the funny thing is that even when we change our IP address, it shouldn't affect our load balancer. Let's quickly refresh. Yeah, you see, still serving from the different servers. So that's fine. So let's go ahead to destroy these resources we've created so that we don't get charged. The first thing you want to do is to disassociate. You can actually just drop your instances and should disassociate it automatically. But you could actually go here, mark this, scroll down to disassociate our Elastic IPs this way. Hold on. Let's pick one at a time. Okay. Let's pick the second one. So now they've been disassociated, we should be able to release both IP addresses. Yeah, so that's that. We'll go back to our instances. We can now terminate both of them. Yep. Then we can add on to our, I think we'd have to drop our load balancers first of all, because our target groups are actually being connected to our load balancers. So if we try to drop our target group before dropping our load balancers, I don't think it will work. Let's just try that first of all. Exactly. So, the target group is currently in use by listener. So let us go to our load balancers. Let's drop this one. Delete load balance. Confirm. Great. Then I think we can drop our target group now. Why my screen is now? What's going on? Okay, so we can drop our target group now. Yeah, perfect. We could also drop our load balancers security group that we created for once. I'll just delete everything. And that's that. We have fully deleted all the resources that we created. Let's go back to our home console. From this diagram, I think we're able to achieve this setup. We're able to create our VPC, and within our VPC, we had our load balancers, we had our target group, and our servers. Within our servers, we had our applications, and users were able to access it. So I think we're able to achieve this setup. And you can see that it's essential to use load balancers for creating a robust, scalable, and highly available web application. It ensures that your application can handle varying levels of traffic without compromising performance or reliability. This diagram effectively demonstrates how a load balancer connected to an internet gateway distributes traffic across multiple instances, right, within a VPC to achieve like this goal. So I hope this video was helpful. I hope you learned something new. If you want me to create a video on something, you could hit me up. You could leave a comment below. Don't forget to like, share, subscribe, and comment. Thank you for watching.